Okay, so in the last video, I did a long division polynomial problem and talked about how to analyze the quotient, which gives you the end behavior asymptote. And it could actually be some weird curvy asymptote, which is what we got in the example we did. In this one, you don't always have to do long division in every problem. Sometimes, well, a lot of times it's sort of annoying. Synthetic division is a shortcut to long division, but there's a restriction on it. You can't just do it with anything. You can only do it if the divisor that you have here. So let me write this. For synthetic division, the divisor must be a linear term with coefficient 1. Right, so basically that means it's in the form x minus some constant, or x plus a constant, however you want to think about it. But most textbooks say x minus a constant. So in this case, k is 3. So to review synthetic division, because you guys should have seen this before a lot last year. My guess is you probably did quite a few problems just to practice it. Different people write these symbols differently, but I tend to do one big long L like that. And then instead of writing -3 out here, you write +3. You actually flip the sign. So since k is 3, it's whatever the k is right here, just that. So if it said x plus 3, you put a -3 there. Then you put the coefficients of the numerator here. So it's 5x to the 4th, 2x cubed. Notice there's no x squared, so I'm going to put a 0 here. -8x, and then 1. And then what I tend to do, this is the way I learned it, I put another line here, and I bring down the 5 right away. You always bring down that first term. So the way to get this term is to say 3 times 5, so that's 15. And then I add straight down, and that gives me 17. And then I do 3 times 17, and that's 51. And then I add straight down, and I get 51. And then I do 3 times 51, and so that's 153. And then I add straight down, and I get 145. And then I do 3 times 145, which is 435, and then I add straight down, and I get 436. So that's just kind of a standard, set of rules to follow there. If you want to see how it works, I recommend doing a YouTube search for Khan Academy synthetic division explanation or how it works, something like that. They have about a 10-minute video that I think is about as good as you can get for explaining how synthetic division actually works and why it works the way that it does. They do a long division problem right next to the synthetic version. So this right here, so then this isn't an answer because it's just a bunch of numbers. Our problem was 2 polynomials being divided. So the way you interpret the answer, this guy right here, that last term, that's always the remainder. And then you work your way backwards. So the 145 is your constant. This is your x term. This is your x squared term. And this is your x cubed term. And if you think about it, 5x to the 4th divided by x, that ought to give you x cubes. So my answer here, if I rewrite the problem, 5x to the 4th plus 2x cubed minus 8x plus 1 divided by x minus 3 is going to equal. And then I'm just going to take my answer right here. This is my answer, right? So remember, you can always write a rational function, polynomial over polynomial. So rational, so like polynomial divided by polynomial. You can always write that as quotient plus remainder over divisor. That we talked about in our last video. So in this one, my quotient is 5x cubed plus 17x squared plus 51x plus 145. And my remainder is 436 over my divisor, x minus 3. Okay. And so let me highlight some stuff here. This is my quotient. This right here is the remainder over the divisor. And notice, remember in the last example, the remainder always has to have a degree less than the divisor. So the divisor has x to the 1st, the remainder has x to the 0, so that still fits. And if I go way out to infinity or negative infinity, this divisor becomes really, really big. you know, if I plugged in infinity there, it'd be 436 over like a trillion, right? So that gets really close to zero way out at the ends. So that's why q of x, since this thing disappears as x goes to infinity or negative infinity, I'm only left with the quotient. So the quotient determines what the end behavior looks like. And in fact, it's called the end behavior asymptote. And in this case, it's an x cubed term, so it's a cubic asymptote. And remember, cubics are curved, and all curved asymptotes go into the family curvilinear asymptote. So I'm not going to graph this thing, but if we did graph it, I'm not going to actually graph it. I don't know exactly what it looks like. I know that it goes through 145, this asymptote. So, and it's cubic, and it's a positive cubic, so it's going to do something like this. Now, I don't know where this graph gets messed up, but I do know that the graph of this thing is going to have to look an awful lot like this cubic way out at the ends. I don't know what it looks like in the middle. I just know that at the ends, it's going to mimic the cubic function here. You'd have to pick a good window for it, though. Notice the numbers are going to get pretty big pretty fast, so you'd have to probably zoom out pretty far on the y's. So, that's it. That's all I have. Actually, why not? Let's go ahead and graph it just so you can see. So I'm going to go back to Wolfram Alpha, and I'm going to type in the original problem. So the original problem was... Actually, I'll do asymptote. So the original problem was 5x to the fourth plus 2x cubed minus 8x plus 1 divided by x minus 3. So let's see what that looks like. Okay, vertical asymptote is going to occur around 3, right? And you'll see it in the picture here. There it is, right at 3. And then notice there's that cubic right here, right? And as you zoom out from the graph, the middle, you know, if you cover up this middle right here, it looks an awful lot like that cubic function. 5x cubed plus 17x squared plus 51x plus 145, which was the quotient, ignoring the remainder over divisor, because that turns into 0 way out at the ends of the graph. Okay, and also notice this is way zoomed out on the y's. The x's are still negative 10 to 10. So you know, if you graph this thing and you're wondering why doesn't my picture show, it's because you're probably only looking at this tiny little region right here. So make sure that, or this region, kind of a really thin, long rectangle there from negative 10 to 10. So, okay, I hope that helps a little bit. And it should help you if you missed class on, what was it, like Thursday or Friday. All right.